Hello guys, welcome to another new YouTube video. So today we are going to be talking about data types in Rust. I've already set up the my work environment and everything. You can go ahead and create a new project with Kaggle new and the name of the maybe data types basically, and you'll be able to generate a new project. So today we are going to be talking about data types as I spoke earlier, and yeah, let's get right into it. So in Rust, every value has a certain data type. This tells us what kind of data is being specified, so it knows how to work with that data. We'll look at two types of or two subsets of types in Rust, which is the scalar type and the compound type. So we have the scalar type and the compound type. Yeah. So keep in mind that Rust is a statically typed language, which means that it must know the type of variables at compile time. The compiler can usually infer what type we want to use based on based on the value and how we use it. In cases when many types are possible, such as what we did in the one of our videos where we built a guessing game where we had to convert a string to a number, we must specify the type annotation. We must add the type annotation, if not, we'll get an error. And I'll quickly give you an example of this. So we did something where we converted a string to a number. So we did something like let's yes equal to got a string. So let me say 100 from the terminal, and we passed it. Use expect. You can just say invalid number. So if I print this, so print line, and I pass in yes, yes, save. If I run this code, we'll get an error saying invalid type annotation or something like that. Cover run. Yeah, so I get this error, and the major part of this error is where it says type annotation is needed, basically. So what this is saying, what Ross is telling us here is that we need to specify the type annotation. So it's in this kind of situations where we must specify the type annotation. So quickly, I would go ahead and specify the type annotation here. I'll say, let's give it 32 type, save, and run the code again. As you can see, we've been able to convert it from a string to a number. So in this kind of cases, we must specify the type annotation. So now we'll talk about scalar types. A scalar type represents a single value. Rust has four primary scalar types, which includes the integers, Boolean, characters, and floating point numbers. This might be familiar from other programming languages. So if you have experience in other programming languages, this should not be a new thing for you. So let's jump right into the types, the scalar types. So we'll start from the integer type. So basically, an integer is a number without a fractional component. So this would be basically something like, let me say 5, or sorry, 1, like I wrote there. So put this here and say something like this is an integer, 100 is an integer, or 1000 is an integer. So anything without a fractional component is considered an integer. We used one of the integer types here, which is the U32. And this type declaration indicates that the value is assigned, that we assigned it with, should be an unsigned integer that takes up to 32 bits of space on the operating system. So take note, we have two types of integers. So we have the signed and the unsigned variants basically. So I'll quickly draw up this image. So we have an image here that shows the signed and the unsigned integers. So the signed starts with an I and the unsigned starts with a U. So I'll come back to this. So moving forward, I'm talking about integers. So each variant can either be signed or unsigned, as I've mentioned, and has an explicit size. Signed and unsigned refers to whether it is possible for the number to be negative. In other words, whether the number needs to have a sign with it. So if it is signed, that is having a sign, or whether it will only ever be positive and can therefore be represented without a sign. So in that case, when it is represented without a sign, it is unsigned. So each signed variant can store numbers from minus 2n minus 1 to 2n minus 1 inclusive. I know this is sounding kind of complex, but I'll explain them. I'll try my best to explain it. And in this case, n is a number of bits that the variant uses. So an example of this is an i8 can store numbers from minus 27 to 27 minus 1, which would be minus 128 to 127, while an unsigned variant can store numbers from 0 to 2n minus 1. So a U8 can only store numbers from 0 to 28 minus 1, which equals 0 to 255. So let me quickly write this out. So I would say for signed variants, the signed variant can store numbers from minus n, where n is a number, minus 1 to 2n minus 1 minus 1 inclusive. So it can store this. And in this case, we already know that n is a number. So basically, an i8 can store. So we would say an i8 can store numbers from minus 27 to 27 minus 1. So, and this is equal to, the same thing as saying minus 128 to 127. This is for the signed integers. So just comment this out. And we have the signed, signed variants. So the unsigned variants can store numbers from 0 to 2n. So can store numbers from say 0 to 2 over n minus 1. So in this case, an i8 in this case, not an i8, sorry, a u8, because this is unsigned. So a u8 can store numbers from 0 to 28 minus 8 minus 1, and so which is equal to say, or the same thing as saying 0 to 255. So additionally, the I size and the U size type depends on the architecture of the computer your program is currently running on, which is is denoted on this table. So you can see here the ARC system. So on a 32 bits, on the ARC system. So we have the 32, we have the 64 bits, and we also have the 32 bits architecture, basically. So This is like all you need to know about the sign system. You can always take a screenshot of this or try to study this more. Basically, we have I32s, which are we have the I8, I16s, I32, I64, I128, which are the signed, and the unsigned, which are the use like the use 8, U16s, U32, U64, and U128. So you might ask, how do you know which type of integer to use? In a situation whereby you're unsure of the type of integer to use, I think starting with the I32, which is the default in Rust, is a good place to start.
Okay, so now let's talk about the floating point system. So Rust has two primitive types for floating point numbers, which are numbers with decimal points. Rust floating point types are F32 and F64, which are 32 bits and 64 bits in size, respectively. The default type in Rust is the F64 because of the modern CPUs. So, but it's roughly the same speed with F32, only that it has more precision. So all floating point system in Rust are signed, basically. So let's look at some example. So we'd say let x equals to 5.9, and by default this is an F64. But if we want to create um, F32, so we'll say y, and we'll use type annotation here. So we'll say F32 equals to 9.8. So 9.8, and this is floating point type of F32. Floating point numbers are represented according to the IEE 75 standard. I'll be adding a link to this if you want to do some further reading. But basically, um, it's the way in which floating point formats are represented in hardware. So I found this amazing article that talks about the IEE floating point presentation, an article from Microsoft. I'll be adding a link in the description. But basically, it says a lot of things about the single precision and double precision, where the F32, even in Rust, is a type of single precision, while the um, F64 has the double precision. So you can do like your further reading on this if you're interested in it. But I think that's about that for floating point types. So we'll be moving on to numeric operations. Yes. So numeric operations, Rust basically supports mathematical operations, um, all the mathematical expressions you expect for all the number types or integer types, ranging from addition to subtraction, multiplication, division, remainder. So let's quickly see some of them. So we'll start with first one. So we'll start with addition. So let's start with addition. So it's the same thing as with other languages. If you're familiar with JavaScript, Python, C++, and stuff. So we'll say let sum equals to 10 plus 20. So if we run this, we know that definitely we'll get some value of 30, something like that. So this is how we do addition. We'll also do for subtraction. Subtraction. And say let difference. Let difference be equal to 100 minus 40, which definitely will be us 60, minus 40, definitely give us 60. And the next one we'll look at is multiplication. So, multiplication. Here I would say let's product, let's say 5 multiplied by 5. And the next one will do division. So I would say let's truncated equals to -5 divided by 3. It's not supposed to be. So basically the result of this will give us -1. If we run that, we'll get so the results in a -1. We also have under, so this is basically for division. Sorry, I didn't add that. We also have coefficient. So coefficient 5, 6.7 divided by 32.2. That would do like divisions in numerical divisions. We also have a way of doing reminders. So in JavaScript, this would be something similar to the modulo operator, the modules. So here I'll call it reminder. Say let's rem. Yeah, because I don't have strength to write out the reminder completely. 43 percentage sign 5. So each expression in this statement uses a mathematical operator, as you can see, to evaluate to a single value, which is then bound to each of these variables. So let's move on to the next one, which is um, which is the Boolean type. So I think I did not add that to my list, but I'll just go ahead and add it here. So the next type of scalar type is Boolean. So Boolean is pretty much the same with every other language. If you have background in any other language, okay. I think I made some mistake here. Okay, so I'll call this Boolean type. So it's pretty much the same with every other language. So a Boolean type has two possible values, which is true or false. And then Booleans are 1 byte in size. So in Rust, the Boolean type is specified using bool. So let's let's make an example. So let's say let's t for true be equal to true, and if we want to create for false, we would say with a type annotation. So we say let f say bool is equals to false. So here we are setting it with an explicit type annotation. Type annotation. So this is the main way, the main way in which we use booleans. Boolean value is through conditionals, such as when we are writing like an if expression or something like that. Would cover more on how expressions work in Rust when we get to the control, when we get to talk about control flow or control flow in Rust, basically. So next we'll move on to the last but not the least, the character type under the scalar type. So let's talk about the character type. So Rust character type is the language's most primitive alphabetic type. So I'll give you some examples. So let's quickly just have some examples. So let's say something like let's let C be equal to something like A. Let me just use small letter A. So A. Yeah. Also have want to use type annotation, explicit type annotation, we can say let E. So we say char, which is for character, equals to E. Um, so we can also do things with other stuff like emojis and the rest. So we can say let's um crab, say roast crab equals to something like that. So let me try to bring out the emoji stuff on my laptop. Exactly. So here um I'll search for some put this here. Yep. So we can also do that too. So if you take notes, you would see that we specify character literals with single quotes as opposed to string literals, which uses double quotes. So this is something to take note of. Um, you see that I used single quotes here, not double quotes. Rust character type is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCIIs. So in Rust, accented letters, Chinese, Japanese, Korean characters, emojis, and zero with spaces are all valid um, character values. So take note of this. They are all valid character values. So next we'll go into compound types, which is the second type of the subset of the data type. So talking about compound types. So compound types can group multiple values into one. Rust has two primitive compound types, which are the tuple and arrays. So a tuple is so we'll start from talking about a tuple. So basically, a tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have fixed lengths. Once declared, they cannot grow or shrink in size. So let's look at some examples. So here we let's create a tuple. So we'll say let tuple, and we'll say let our tuple will contain um, an I32, a U8, and F64. If we do this, we'll equate it to something. So we'll say, so I32 will give it a number. We'll say, let's say it's 400. U8 will give it 2. The F64 will give it 19.3. And the pool will give it value of 2. So the variable here, the variable tup, that is tup. Let me scroll up a little bit. Yeah. So the variable tup here binds to the entire tuple because a tuple is considered as a a single compound element. So to get the individual values out of the tuple, we can use a pattern called destructuring to like use pattern matching to destructure a tuple value basically. And how this would work is basically we would say if we want to get a value from this, we can say using destructuring. If you're coming from a JavaScript background, you'll be familiar with this at least. So we'd say let's say A B C and D, and would equate it to the tuple as a tuple variable. So if we go ahead and print, so let's print line, and this our print line. Say the value of C is like this. So before I run this, I'll just go ahead and comment out every other of our code so we don't have unnecessary panic in the console. Yep. So so I'll just go ahead and run this code, see what we get. Oh yeah, so there is an error here. I skipped the equal to, so assigning it. So I would say 2 is equal to this. I save and I run it again. Okay, so I've seen the bug here. The issue here is me adding this. So okay, so it's saying could not compile data type, okay, to previous errors, and if you read the error message, it's saying something about one positional argument in format string, but no argument you're giving. I'm trying to understand. Yeah, so here it says unknown format trait, so C. So it's an unknown format. So I need to remove this and run it again. So that was this and run. I will run. Again, save. Save. Yeah, so you see the value of C is 19.3 basically. So 19.3, this is it, F64, and C here, tuple, so the third one, so we're using the structuring to print it. So basically what we did here is the program, we first, created a tuple and bind it to a variable, and then we use, we destructured it, and after destructuring, we finally printed something to the console. We can also access, tuple elements directly using, the period syntax followed by the index, something like that. So we can say, we can also do something like, let's say it's for HNTERED, so 800 be equal to this. Close this, and here I'll close this too, and use another print line here. Just want to make things concise, simple. Okay, so I'll say I'll just call this Guys, I could actually edit out all these bugs that I'm having and stuff, but what's the fun in it? So I'll leave it there. And then, so when I run this code, so clear, and I run it again, it's getting an error. Okay, I did not save. I have to save. Save this and run it again. Then I will run. Exactly. So I get 400. So I can use the dot syntax. So two dots. The first one, which is 400, to also get that value. So the tuple without any value has a special name called the unit. This value has its corresponding type. You know, the value, like, it has its corresponding type to parentheses, which is represented by empty parentheses, and it's still the same to what expressions implicitly return when there are no values. So basically, what I mean by this is a tuple that has no value returns an empty parenthesis. So tuple with no value returns empty parenthesis, basically. So let's go on to the next one, which is basically the array types. So it's another primitive compound type in Rust. So the array type, talking about the array type. So unlike tuples, every element of an array must have the same type. And unlike arrays in other languages, arrays in Rust have a fixed length. So it's very important to take note of that. Unlike tuples, every element in an array must be of the same type. So we cannot have F32, I use U8, and I32s and all that. It must all be of one type. And unlike arrays in other languages like JavaScript, Rust has a fixed array length. So let's look at an example. So we'll say let's A equal to 1, 2, 3, 4, 5, 6. So this is like array. So arrays are useful when you want your data to be allocated on the stack, or when you want to ensure that you always have a fixed number of elements. An array isn't as flexible as a vector type, but it has its own use cases. So you can write array types using square brackets, as you've just seen. So let's say we've already written our array and we want to give it a type. So we'll say our type annotation, we'll use another array bracket and we'll say we want this to be a type of I32, I32, and we'll separate it by semicolon, and we want the length to be 5 or 6. So we want the length to be only 6. Yeah, only 6. So here the I32, is the type of each of the elements, and then the number 6 indicates the array, the number of elements in that array, or the number of items that an array is a single chunk of memory, with known amount of space in the memory, or something like fixed size that's already allocated in stack. So you can access elements of an array using indexing. So what this means is, if we want to access elements in our array, so like for instance this array, we can say, let's say we can do something like this. Let's first equal to A and use brackets and put 0 there. So this will get the first element in the array, which is 1. And then if we do something like let second equals to A1, get the second element in the array, which is 2. So phase two. So another thing again is talking about invalid array element access. So if you try to access an element of an array that has passed the end of the array, Rust will panic. So this is like how Rust tries to enforce safety principles, making sure that you don't access invalid memory. In the future videos, we will discuss more on Rust error handling and how to write safe code. And there you have it, folks. We've covered a wide range of topics, from ranging from scalar types to compound types, including arrays and tuples. It's been quite the journey, and I hope you found this both informative and engaging. And remember, whether you're dealing with integers, floating point numbers, booleans, or character, Rust got you covered. It's a language that emphasizes on memory safety and helps you avoid the common pitfalls in low-level, programming. I'd like to remind you that when working with arrays, always be cautious about your indexing. Rust's memory safety principles ensures your code won't access invalid memory, but it's essential to understand how to handle such cases. If you enjoyed this video and found it helpful, please don't forget to give a thumbs up and share it with others or your friends and all that who might find or benefit from this knowledge. If you have any questions, suggestions, or if there are any specific topic you would like to see in the future, please leave a comment down below. I'm here to, provide more content that you'll be interested in. Thank you for tuning in today, and I look forward to seeing you in the next one. Until then, happy coding. Peace.